Hello everyone, welcome back. Today we are going to be diving into an interesting problem. We are going to calculate the average distance between points on a line of length L. But here's the twist. We won't be using integration, but rather, instead, we'll tackle this challenge using only combinatorics. To solve this problem, we will break it down into a few clear steps. First, we will calculate the total distance on a line with points that are evenly spaced at a distance of x. Next, we will find the average distance by dividing this total distance by the number of pairs of points. After that, we will set up a formula for the average distance in terms of p, where p represents the number of evenly spaced points along a line of length L. Lastly, we will take the limit as p approaches infinity to determine the average distance between points on a line of length L. To start, let's calculate the total distance between p evenly spaced points. Imagine that we have p points evenly spaced, where the distance between each adjacent pair of points is x. Our goal is to calculate the total distance between all pairs of points. Let's start by looking at points that are x units apart. Each adjacent pair represents a distance of x. Since there are p minus 1 segments between these points, we find that there are p minus 1 pairs of points with this distance. Now, let's consider pairs of points that are 2x apart. This means we are looking at pairs that occupy two adjacent segments. We can only start placing these pairs from the second spot up to the p minus first spot, and this gives us that there are p minus 2 pairs of points that have a distance between them of 2x. Following this pattern, we can derive that for distances of 3x, 4x, and so on, the number of pairs continues to decrease. P minus 3 for 3x, p minus 4 for 4x, and so on, all the way down to just one pair, or a length of p minus 1 times x. So the total distance can be expressed as a sum of all of these smaller distances, which is equal to p minus 1 times 1x, plus p minus 2 times 2x, plus p minus 3 times 3x, all the way up to 1 times p minus 1 times x. Let's factor x out of this sum since it's a common term and get x times p minus 1 times 1 plus p minus 2 times 2 plus p minus 3 times 3 all the way up to 1 times p minus 1. I'm now going to do a little trick here for the last term. I'm going to write 1 as p minus p minus 1. So now I have x times p minus 1 times 1 plus p minus 2 times 2 all the way up to p minus p minus 1 times p minus 1. I can distribute in my constants and get p minus 1 squared plus 2p minus 2 squared plus 3p minus 3 squared all the way up to p times p minus 1 minus p minus 1 squared. There are some formulas that will help us out here, mainly the sum of the first n integers, n times n plus 1 divided by 2, and the sum of the first n squares, which is n times n plus 1 times 2n plus 1, all divided by 6. Now, I want to group together the positive and negative terms. My positive terms are 1p, 2p, 3p, all the way up to p minus 1 times p. My negative terms are 1 squared, 2 squared, 3 squared, all the way up to p minus 1 squared. For my positive terms, they all share a common factor of p. So I can factor that out and I'll be left with p times 1 plus 2 plus 3 all the way up to p minus 1. This is perfect because 1 plus 2 plus 3 all the way up to p minus 1 is just the sum of consecutive integers. We can use our formula of n times n plus 1 over 2 to calculate what the sum is if we just substitute in p minus 1 for n. When we substitute in p minus 1 for n, we get p minus 1 times p divided by 2. So we now get that the first part of our parentheses is p times p minus 1 times p, all divided by 2. If we now focus in on our negative terms, we see that those are 1 squared plus 2 squared plus 3 squared, all the way up to p minus 1 squared. We can simplify this by using our sum of squares formula. Plugging p minus 1 into our sum of squares formula, we get p minus 1 times p times 2p minus 1, all divided by 6. We have now simplified our sums in terms of p. We can further simplify this down to get p plus 1 times p minus 1, all divided by 6. Thus, we get that our total distance is equal to x times p plus 1 times p minus 1 all over 6, where x was the distance between adjacent points. And there you have it, the total distance between all pairs of evenly spaced points. We are now going to use this result to help us calculate the average distance between our points. I would like to note two things before we move on. One is, normally we would have to use induction to show that our distance formula holds true for all p in the naturals, but I will omit that because it is just busy work. The next is, you might be worrying that we might have missed some distances. If we look back at our segments, we'll see that we had one segment of length p minus 1x, two segments of length p minus 2x, and this went all the way down to p minus 1 segments of length x. If we add up all of our segments, we get p times p minus 1 all over 2, which is known as p choose 2. Therefore, we ended up getting all possible distances between pairs of points, so we don't have to worry that we missed any distances. Calculating the average distance between evenly spaced points is relatively easy. All we need to do is take our formula for the total distance that we just found, x times p plus 1 times p minus 1 divided by 6, and just divide that by the total number of pairs of points, which is p choose 2. This simplifies down to x times p plus 1 all divided by 3. Therefore, when we have p evenly spaced points, our average distance is denoted by x times p plus 1 divided by 3, where x is the distance between adjacent points. We are now approaching the finale. We can use our average distance between evenly spaced points formula to help us find the average distance between points on a line of length L. We're going to imagine that we have a line of length L. Now, we are going to distribute p evenly spaced points on this line. Since our points are evenly spaced, we can calculate the distance between adjacent points. This is going to be L divided by our number of segments, which is going to be p minus 1. We can now substitute this in for our x value for our average distance formula. Substituting this value in for x, we get that our average distance between our points is equal to L divided by p minus 1 times p plus 1 divided by 3. This gives us the average distance for a line of length L that's been broken down into p evenly spaced points. We want the average distance between points on a line segment, not just a finite number of points. To do this, we will have to take the limit as our number of points approaches infinity. Taking the limit as p approaches infinity of our average distance formula that we just set up, we get L over 3. And there you have it. The average distance between 2 points on a line segment of length L is L over 3. I hope you found this video interesting, and I will see you in the next one.